our objective of today discussion, right? That webinar. So I have divided that part into the two my Jupyter file. So we are going to see directly the implementations, right? And in between, I will be tell you about how I'm using it and what is the impact of that particular line of code to generate the answers, right? So initially the first one you can see over here. So first of all, I'm just so let's what is the objective? So objective is very simple. I want that we are having huge database which is available online, right? And the few GitHub repository by John Hopkins University. So we are having the huge database. So with this database, we are going to be what make the model. So the prediction model for the next 7 days. So what will be the COVID-19 cases in the next 7 days? So that is the what man. So for that, first of all, you have to be have a clear understanding about the what data set, right? So there is one data set which we are going to be use over here. That's the COVID cases in India, right? So let's start with the first, right? The as you can see here, the very first interpreter. So that's a Jupyter one. I hope you guys are very much familiar with this. So that's very easy and very interactive, and you can have your own documentation. So we use the Jupyter in that purpose. So you can see here, so I used a couple of libraries. So NumPy, Panda, Seaborn. So the NumPy is what package stand for the numerical Python, and that is the core library for scientific calculations, and which contain the very powerful and dimensional array objects. So that's a role of the NumPy here. Pandas. So pandas is designed in top of the what NumPy, right? This also having the support of the NumPy, and that's another different type of data structures which we call as a data frame. And the data frame is a different one, right? Because that data frame we use to store the data in a row and column format, right? So the row column measure, so we generally call as what database, relational database. So that we use here. The Seaborn is another one library, which is another very interactive library for the graphic purpose, and that is built on top of the what Matplotlib. So all are the open source library. Matplotlib is the one visualization, uh, you can say data library in a Python. So which will provide all the different types of charts available and make the data which is visualized, right, in two-dimensional data. And this line is what especially for I want to be just show all the graphs into my own uh, Jupyter. So that's why we use generally this one. Wait a minute. Yeah, it's working. So now first in the next one you can see the very first COVID-19 case which is analyzed. So I just get through with the Google, right? So on 30 January very first case is reported in India. So the one students arrived in Kerala from the one. So the very first case we identified on 30 January. Right. And you know, right? So that's COVID-19 is now the buzzword in our in nowadays, right? So similar like the other buzzword we generally we listen in terms of the what technologies, programming sense. So they very first. So our objective is what just make the another model, and we can have a prediction for the next 7 days. So anyone if having any questions in between you can ask, right? So no issue in this. So next thing is what I use the PD as it is what pandas object, right? So pd.excel is a function which will read that file. So all my all these stats of India. So I just make another Excel sheet, right, which having the all the informations related to the COVID cases. So the total cases, the cured cases, death cases. So these all are the cases. I'm just making another copy. So in between, if I want to change anything, which will not be affected, and my changes will be done in what DF. So that's what data frame we call. So the main powerful part of the word pandas. So data frame, rows and column. So all the columns on the all the rows are different samples. All the different columns are the what uh, attributes we call as it. So as you can see here, so when I'm going to print df, so just simple, the whole Excel sheet will be here, and there is a one column which is index column by default generated by the pandas, right? And the other columns which is what inside in my Excel sheet, you can see. So these Excel sheet contain the information. So I just scrap the from the, so there is you can see the state confirm cases, the and cure and death case for all these states in here, right? So over all 31 different 31 different states and all the data, right? So this is the what first sample data frame which I just generated using the pandas. So df will store everything inside df. Now let's print the total COVID-19 cases in India. So the simple thing is what we use just simple formula, because as you can see here, total cases will be the what total national and foreign national. So including I have to submit national and foreign national, then only I will get total cases. And you can see in actual there is no total cases column available. So I'm making the another column in my data frame, and which will be the name as the total cases, and that will be generated by this one. So now you can see the again power of the pandas. So the first of all, what I'm doing in this one, so df.drops will be dropping the what serial number, because I don't need that serial number because it generated their own index. So as you can see in the above one, so they are repeating, right? So they started from 0, they started from 1, so I don't need the serial number, so I'm just dropping the data. So that we call as a cleaning, right? We call as a data cleaning. So unnecessary column will be what clean. So and in place equals to true. So once you will use it, so you will get to know that. So in place is the kind of I'm not creating any different object. I'm doing changes in a same object. So different object means different memory. I'm performing the operation over the same df. That's why in place equals to quick sort another. So we don't need the extra space like that. So df total cache is equals to df total confirm cache. So Indian national plus df data frame give the column. So it will extract the all the columns, right? And then the whole data will be stored in a total caches, and I'm going to submit. So total caches dot sum will generate the total caches, and this is our simple print statement through which you can print the what total caches. So just simply what let me again just execute all this statement one by one. So again, it will not be generate any error in further. First, let me again execute this one. Right, we are just calculating the total cache is 4421. So now today is around 6,000 cases we close, I think. Now just print the df, so you will be observed there is a one column will be dropped, right? You can see here, and the one column will be added total cases, right? So now total cases is added. Now we can highlight all the frames. So I'm using some styles over it. So with this, it will be the give the good visualizations. Just simply what Andhra Pradesh having 266. So the any of the state having the maximum cases, that will be more red like that. So the another C map that we call it as a color map, right? So df.style.background underscore gradient will be what it's maybe some the another one you can use. So totally red, dark, light, depend on the what number of cases for the just visualization purpose. So now let's find the total number of active cases, right? These are the total cases, but active cases, we have to be, so total active cases will be what? Total case minus number of that plus cured cases, right? Means recovered cases. So simple one. So I have to be subtract this information from the total cases, and then I will get the total active cases. So we are making another column over the D, and I'm going to, so it will give me the sum of the total cases, and I'm just going to print it in a sorted order. As you can see here, I just group by all the name of the state under union territory, total active dot sum dot sort underscore value. So now it will generate another frame which will be having all the information but in a sorted order. Okay, and then I used another color map code, so which will give another view of the information. So once I am going to run it, so you will be see here that is now sorted. So I hope you can see the 647 cases in Maharashtra, so maximum cases. So total active cases are 3,981 after the cure and death. So again, I'm saying this data is up to the 6th of April, right? So Tamil Nadu is second, Delhi is third one, UP similarly. So all data is sorted according to the order, right? Now I have used another CS value files, which is for the I want that whatever the cases we have noticed in different states, I want to just map it all into the one geographical location. So I have another CSV file which is having the Indian coordinates. Generally we call as a spatial data, right? So as you can see, if I run it, so this will be get run the read the CSV. So one I'm going to read the Excel, so read Excel, and when it is CSV, so read the CSV, and it will be stored into the object called as India underscore coordinate. Let's just print it down. So you can see that CSV file containing the state name, the latitude of the state and longitude of the state. So we call it about geographical information. So basically I'm going to use another library after it to visualize these cases into the what geographically. So you can see, so there is another very good library, the open source library I call as what the following. So this is the another using library for especially for the spatial data, right? So spatial data means geographical data means that the data contain the coordinates, latitude, longitude, such type of, so such type of data information how we can represent interactively. So there is another library is what we call as a following. So it was not present in my system, right? Not installed with a common general Python package. So we have I have installed that package, right? So how we can install it? So exclamation mark pip install and following. So through which we can have installations will be done. Now you can import it, right? So I have imported, so now it will be get import easily. And after it, what I am doing, you can see here, so I have two types of object. One is data frame which will map for the complete India, right? All the cases, and the second one is what Indian coordinates. For all these states there are coordinates, right? So I'm going to merge the two files into the one, and that we call as a df underscore full. And this merging will be happen on the, so there is a very common, right, whenever I'm just going to merge the two tables, so there must be one single column must be present. We call as a what cross operations, or maybe the rename operation, different addition product operations we have in SQL must be what common. So this is the column which is common in the both the data set, both the files. So accordingly it will be merged, right? And now I'm using the map function of the following and presenting in the every state to the what coordinate. Once every state will get the latitude longitude from the given files. So accordingly, so we know that the Maharashtra is having the highest cases and Maharashtra having latitude longitude. So then all these three data will be matched, and my map function will be what plot into the what geographical locations using what following. So again, you can see here, and for this, understand what we are doing. We are putting some pop-up as a what circle, and that circle having the radius. So that circle marker, generally we have in Google Map, we have a marker, right? That pinch kind of thing. So here marker is what the circle, and that circle will be what the size of the circle will be depend on the what how many caches are there. Right, so I just you can see here the big number of caches will have a big circle. Simple. Mm, right, if I zoom out, so we are going to for the India. You can see this is what India map. As you can see, this is the Mumbai. So Mumbai is having the highest cases. So that's why the circle is what the highest. The radius of the circle depend. This is what the Hyderabad, Telangana. So that is state Jammu and Kashmir. So that is the what Delhi. So if we zoom out, so that's all. Again, if we talk about the Gujarat, so we are having 110 cases right up to the 6th of April. So that's another volume is the library, right? So through which we can have a we can visualize all the cases, right? Geographical locations. We call it the spatial data. So basically, that volume of it is spatial data. So that's interesting, right? Now, what we are going to do, confirm versus recorded cases in India. Understand, see, why I'm moving to directly this COVID-19 with Python, because if you know the basic of the Python, so after it you can do the experiment, all the experiment, and that's not a very difficult task. You can do both the things. Now I'm going to be generate the confirm versus recovered cases in India. So see, we are using the plot subplot which will be written toward the figure object and the axis, that is what axis object. So two object will be written by the function subplot, and that ax will contain the number of columns and number of rows. So basically what we are applying over the df underscore full, where the state total cases cured and death, and that's so we are going to plot it another figure we call as what bar plots, where we are having total cases, and so that this is the what bar plot which indicate the total cases, and here is the bar plot for which will indicate the recover. So that's a mixed one. So total cases, and out of total cases how many are the recovered from it, right? So I just put it the x direction limit up to the 500, so you can change it, depend, right? So accordingly, up to the 500 cases, how many cases will be there and how many are recovered. So that will be what shown by this bar plot, right? So you can see the diagram after the compilation is over. Okay, so we can ignore. So now you can have you can see the diagram. So as we have sorted already, so Maharashtra is having highest cases. So up to the 500, you can see. So 500 up to 500, I just set the limit. So how many recovered and how many are there? So you can see. So out of suppose is what about Gujarat? So how many are recovered? So recovered, and so that's called bar plot. So another of the chart, right? Bar plot. The cured cases, cured cases. So how coronavirus cases live shortly. Three-dimensional, I can say 3D graphical, yeah, graphics library in a Python. So that is already installed, right? So no need to be installed. So for it, you have to install it. So there are two functions, two classes, express and graph underscore object I need for the next one. So first import. So whenever you need any library, you just import first, make the object and use it. Now what I am doing, so per day cases in India. So there is another I have, right? So per day cases is there, and that's a date wise. So you're having dates, the very first case, second, third, fourth, what 2 days, so having all the cases called as a DBD underscore India, right? So per day cases will be stored into the one another data frame. We call this one, and another DB underscore India. So you will see the how it's look like. So there are three sheets inside there. So let me show you over here as well as I have already one. So like Italy and Korea, we can have a comparison after it. So we are going to be compare it. Fine. So let me execute this one. So you will get the what you can see the sheets at the India, and I make the data frame object install into the what data frame. So all the records are here. So as you can see, the dates are here. So I received this data from the job option university, right? So in which I have only data up to the 25th of March. So we're going to analyze to that, right? So it's fine. No, prediction model I have 6 to 7 of April. So right. So similarly, so in this now I'm going to do 19 cases in India. So how many cases, total cases, recovered cases, dead cases. So as you can see here, so this is the data available in the sheet, right? How many columns are there, new cases, active, recovered, and dead cases, total cases. We are going to be plotting. So go dot figure, so go it's the object. So with this, we are going to be what make the another plot, right? So the cases. Why it's not showing? Oh yeah. So let's to the other part. So no, you can just compile. So it will become something which we are doing. So let's take the another one. So we are having two countries data set, Italy and Korea. So I'm just going to compare with India, right? So I have to do another. Right, so the another two frames is built. Now we are just comparing all. Yes, something is missing, which is not qualified. Mm, calling that this is the graph, the bar plot. basically this function this written different graph fashion. And, we can show the comparison between the how many cases was there in the separately Italy, Korea, and finally in the last one. So here in the that these are the same one. So actually in this one we are showing the vertically, as I've said that the orientation is vertical fashion. In this one, what I'm doing, I'm just spanning the total canvas into the one. So there are only one canvas which we are going to perform, as you can see, rows and columns. So total space will be used, and all the three countries cases will be shown in a single canvas, right? And different color set. Let me see. Why it's not. So here you will get three diagrams, right? Just which I miss out. Important. 132. Exhibit 33. So, okay, you also get it. So I will post anything I miss out to not getting. So these are the references which I have used. So one Kaggle competition was there. So through I get the data set and few of things. Another data set I get it from that GitHub repository. Some of the coding part where I just stuck. So I use it. The another YouTube video which I refer it for the understanding the few things. So you can use that references. Now next move to the next part. So see what we are going to do in the next part. So in the very first part, we are just working on the data set of the Indian states, all the different state and union territory, and the different and comparing with the other side. And what we are going to do we are just going to perform the forecasting, or maybe I can say the prediction, or the aim is what to predict the next 7 days COVID-19 do it. So it will be quite complex. So don't feel it's more complex. So it's just practicing. So if you do practicing, so it will be easy for you again. So again, I'm using NumPy and Panda. So I already given the introduction. OS you can use, but in this case, I keep all the files into my SAM folder. So this OS modules, OS library here. So, again, so from the related library side, how I get all the diagrams over here. Another, so here I'm using the another libraries, PyCountry and PyWaffle. So these are the another is open source. So where the PyCountry is a kind of the library we can use to code and that. Waffle is chart, right? Waffle chart is a kind of a grid chart. So all the grid will have some up and downs, right? So the waffle, so we call it a waffle. For Lim we use the last one. So I already installed. If you don't have that library, so explanation mark we install the particular library. That pipe and then library will be available. Fine. Now, so let me compile it once more. Now, so there are three files which we are going to be used now for the forecasting, because and that file contain the word global information, right? So all the countries informations with the date wise, right? So the columns are the country names. So one by one we will do the filtering part for the individual. So confirm cases, recovered cases, three time series data for confirmed cases, recovered cases, and death cases globally. Understand, right? Globally. So I use that data set from John Hopkins, from the GitHub repository of. So now just see. So we are having another different data confirm, recovered, and death. Right. So I have to do some key process tasks for the confirmed cases. So you can see here. So if you want to see the confirm data, so that is the what you can see here. So columns are there 81 columns. So head is the function will return the top 5. If you use tail here, it will return the, you can see. So it will be 262, and that's you can see from 1, so 22nd January to 7th. So we are having all the time series of data. So this is for the confirm, and similarly we are having another 2 data frame for the what. So if you want to see the all the columns for the filtering purpose, that is the what attribute. So it will print the columns. So columns started from this date and then what up to the 7th of April. So I have data from up to the 7th. So now you can see here, I don't need I need what the reason that is enough. I don't need that audience is stay that long right now. So that's why what I'm doing. So I'm just dropping the column in a same object. So that's why. And the rename it is quite complex. So I have to change into the word region. So that's some changes. And after the again you just you can see the changes. So the 2 column was dropped and the 1 column was renamed and the other it is right. So now a list of countries to analyze. We're going to compare with Italy, South Korea, and Spain, right? And as you can see here, what I did here, so the data is now in the form of the what I just did the transform. You can see here. So basically, original data set, the name is what in a column. So we convert into that, and all the dates are in a column format. So we convert into the rows. So that's a simple transpose we did, right? Row and column. So column will become row and row will become column, and then 5 add informations we printed, and trees will be become as a column. So for only 5 countries. So we filter from the data from the 5. So is the what list. We are making that list. So that plot country list we have Mac because we want to compare between that, and then from the df underscore confirm df underscore will be create another list from it, and then we are going to be transport this and then print the first. So as you can see, so it is a simple one. So it's showing 131, 133, 137, 143. So because this is the what the sequence, right? You can see in the original one the data is, so that is the sequence. So accordingly it will get filtered. So I am just going to be replace it. So this is what another dictionary which I make as a column. So one will be represented as year 137 and Italy. So we replace it. So 131 will become what India. That column not needed more and more and by the column date. So that is what date. So that is what our date over is one. India line. Okay, so this is again for the head. I can go for the 10, so we will get the data. So we have up to the what 7th of April. So cases in India, Iran, South Korea, so that's data up to the what 7th of April. Now we have to do some another pre-processing to the recovered file. The similarly same processing we will do. So first is confirm one. So second is what recovered. So same thing we will do for the recovered file. So similarly, you have to just do the same code, copy paste, and do for the data frame for the recovered. Right, the same one we are going to do it. Now this one we are going to drop the columns which is not be needed. Then reverse it. So now we are positions and convert the particular name, the country name, done. Right, so the one column is coming extra, so that's why we just click it now and just print. So again the date and this one. Similarly for the death cases, so that data frame, the same have to just the columns for the death sheets and unnecessary columns which are created subset by country. So now again just do the same thing, just replace the make another dictionary for it and replace the number by the country name. So now it's again done and the first column will be that. So we change the name right. Now it's done. So now compare spread across the country. So we are able to inform recovered and death. So we are going to do what make the copy of it and index this. So going to first compare all the confirmed cases India, Iran, Italy, South Korea. Right. So we get that. So you can see India, we are quite happy, right? But Italy, Spain, so this is what confirmed. So they reached to the what that number side. Still, our growth is what slow. To that curve, can see related. Again, we are quite happy. Similarly, you can have a recover. So that is graph. You can compare easily the cases. Whenever some of the information is not available, so we will replace it by the word 0 in place, so that the field and not available data. Now cases in India versus death. So now what we are doing, so we are having the confirmed cases, death cases in India, extracting according to the S1 and S2. There are two columns will be created. We are going to make the plot between the confirmed cases and death up to the 9th of April, right? And it will be give me the grid information. So that's why we use over the grid. You can see the another diagram into COVID-19 in India as of 9 you can see here. So death compared to the what? Confirmed cases. So we reach up to the 5,000. That's what our 5,000 usually crossed. You can see. So actual confirmed death. So that is what not extract data from for all the countries, right? So we are extracting the dates. So all the confirmed cases in all countries. So confirm all with the date, and that will be what stored into one data frame. So we extract the countries, get the date column. The date column will be what available as we already add that date. Similarly, we are going to match that's a complex one you are not getting very easily. So the thing is what that exercise you have to be carried out, right? Parallelly, you can go and check it out. Okay, what is the difference between series and data frame in Panda? So you will get the idea. So don't feel that's too much heavy. So it's not too much heavy, right? You have to be do it if you want to be make your work in machine learning and related. So you have to be do it, right? No options you have. I set all the data for all the countries. So here there is one cutoff we I put it right. So there must be some cases at least and should be 50. So greater than 50, then only that will be extracted. All the we use. We are going to be make the another forecast model, right? So for fitting the data into that model, I to the all the data inside it, which will calculate over here. So that is apply over here as underscore India, as underscore Iran, similarly, and it should be greater than 50. So 50 is just simple threshold, right? Put in the number as well as for the experiment point of view. Now creating the data columns, dat columns, sorry. So for every index, so every India, Iran, so because it's generating initially as well as so if it is not generating right now, so it's yes, first this one, that one. So yeah, so in this case, warning is good. If it is not generating warning, means something is not be get executed. Now again, subset of each series for the number catalan. So now finally what we are making the actually that is what a time series function. Understand why we are doing all this? That's a time series function that the data is in continuous data, right? It's not a categorical kind of data. And I have to make the what a complete series of the data, and the time series function I have to be make to perform the forecasting. So that's why we make the series. We are having only the dates available for individual countries. So for one countries, we are having all the dates available from 22nd of January to the what 7th of the March, of the April. So similarly, we are doing for all the one, and we will use this as underscore India underscore G100. That data means that data contain what the what individual date and the number of cases on the particular date. So that is what the information represented. You can see as so let me execute this. So once I will place one, so we are going to get date and the cases increasing. Now similarly we are doing for so I am just making for India, right? Similarly I am using some other countries as well as, so you can do the same exercise for other countries, right? For Iran, Italy, Korea, Spain, US, so for the same thing. So now here, so I'm using 3-degree polynomial functions core number. I'm using not any scikit-learn library. a simple numpy for which is not simple. I'm making 3-degree plan simple. We are having already the data. So through the data, we are generating the initial function. So over it, we are predicting. So what we are going to be forecast. How this is what we call as a model, prediction model. So here we use y as s underscore data and g 100. So y is what? How do you see the data and value of y, right? C is what n range 1 comma length of y plus every day it will be what we start from the first row. We check how many it increases. Again, it will compare to the next. Again, it will be increased. So that x column, x value will be generated with the help of what the y only. So that we call as what forecast, right? And that India TS is what x date will be stored. Fit into 3-degree polynomial. So we are going to fit comma 3, and that's a numpy, the scientific function. So which we use, right? And that is what z. So generate polynomial functions. So and want dz, give the p here, generate x data for the forecasting. So xp is the what data over here, arrange up to the length of the y, generate the forecast over the what xp. That is what the function p, the polynomial functions, which we are going to apply over xp to generate the yp for curve. So see. So now it will be now making the one polynomial equations. So over it we are having some x and y, the 3-degree polynomial equations. The y is the what data, which is what time series data, which we extracted from the series of the time given, right, up to so far. Now here, so what is our aim? So for 7 days, we have to make it. We have to predict. So one function, one exercise we did over here using date time library. So what I am doing over here, so is end date, start date we are finding, and we have to forecast. The forecast we will do forecast for the next 7 days. You can change the number of days, depend, and then it will be extracted from the time from system, and that's available into the format, specific format we have to get specific format is available. Right. So now you get start date, what is the ending date. So you will see start date is what 3rd of 3 means that's March, right? And 7 of 14 and all the date. So x underscore fc, whatever the data which will be stored over here. So that's all are the dates you can see. So from the 10th of the March, 10th March to the what 14th of the, so new data will be generated, and accordingly we are going to make it, and we are going to map it to the what account. Now you can see here, so we are having data which is available, right? We are going to put the data into the what, so xy, xp, yp, which we have predicted using the third equation, which will be fit over the what that looks like simple. So you can see. So if I go and use it, as you can see here, so that diagram will be comes. So actual and predicted. So you can see here that are very similar, right? The line, the dashed line, and the dots line. So the dashed line is what actual one, right? And dot is what predicted. So just the polynomial functions work perfectly, so that we can validate, right? The simple thing. Now with this is another figure, so we can have a line of the predicted case up to the 1st of April, right? So how it's growing. So according to the date, the case available. So I will use it simple. So that's it's showing me up to the 2000. It's around. Just increase the limit. It will go like that. So as we know, up to the 5, 6, 7. So that is are increasing. Right. Now the forecasting. So for the next 7 days, right? So what will be the cases will be increased. So we are going to be predict by that model, the X and Y forecasting model over there. And for the next 7, we need what information, right, related to it. So we're just going to be use it. Again, from the 4th, the cases are these. The 7th April, 8th April, 9. The cases 6, 7, 33, 10th April, 11, 12, 13, and 14. So on 14, we are going to be cross 12,000 plus. So that is what the model is giving the output. So up to the 14, we are having these are the for understanding. So I hope you get something from it, and you have to be again recompile all this and get idea work, right? So in one shot, you just see that much complex. It's quite easy compared to other languages, and you are having and whatever output you will get, the errors, and that's again the big community. Or you can have a lot of suggestions, and this is the very basic one. The aim of this exercise is to make you understand how we can analyze data, which is about machine learning. Every time we have a limitation as a data set. You have to gather the data set, but here we are having data set, right? So everybody is collecting data set, scraping the data set, and the data sets are available. So you can do that one easily now. So we have to apply the machine learning. So these two exercise are just completed. So I hope you guys enjoy, and if you have any error troubles, so leave a message. I will be trying to help you. Right. Thank you.